Hello, my dear students. I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be dealing with another set of questions from Statistics Paper 2 of the year 2026. Those who haven't watched the Statistics Paper 1 series can watch it. We have uploaded that on our channel, and those who have done that can watch this, can continue with the video of solving these questions. So today we'll be taking from again series 1A only. We are considering series A. Those who have series B, C and D papers can see the question. They might be shuffled. The question will be same. The number of the question won't be same. So you can see likewise. And we'll be solving from question number 1 to 10 in today's lecture. Okay. So let us see the first question. I hope that it is clearly visible to all of you. The first question states that let x1, x2, xn be a random sample from distribution for which mean is equals to mu and variance sigma square exists. Then the consistent estimator for mu is. For any consistent estimator, we use weak law of large numbers. WLLN. Now, if we are using weak law of large numbers, then under the sufficient condition, the first sufficient condition is condition is asymptotically as n reaches to infinity, as limit of n reaches to infinity, expectation of Tn, which is our consistent estimator, should be equal to theta, and asymptotically when limit n reaches to infinity, the variance of Tn should be equal to 0. These are the two conditions that should be satisfied by them. So first of all, x1 and x2 do not satisfy this, and even xd and even xn plus x1 do not upon 2 do not satisfy this. So let us check for summation xi upon n. Let us check for x bar. So if we are checking for x bar, the first condition is expectation of small x bar, which will be equal to 1 upon n expectation of summation xi. Now summation we can take outside upon n expectation of xi. Expectation of xi has been given to us as mu. So we are taking mu here, mu into n upon n. So this n and n get cancelled and we are getting mu. So our first condition has been satisfied. Now moving towards variance. Variance of x bar is equals to variance of summation xi upon n. Now we can take 1 upon n square outside. We are left with variance of summation xi. Now we can see that variance of summation xi is nothing but 1 upon n square summation variance of xi. Variance of xi is sigma square, so it will be 1 upon n square n into sigma square, which is sigma square sigma square by n. And when we put limit n reaches to infinity here, then this will be equal to 0. Sigma square upon infinity will be equal to 0. So hence our statement 2 is also verified. Sufficient condition second is also verified, and hence our option number C, which is summation I goes from 1 to n xi upon n, is the correct option for this one, is the consistent estimator for this one. Okay, this was an easy one. Now moving forward towards question number 2. Question number 2 states gives us a PDF theta upon x square. Which of the following is a sufficient statistics for theta? Now we have to calculate the sufficient statistic for theta. For calculating the sufficient statistics, first of all, we have to take the likelihood estimator of theta. So the likelihood estimator of theta would be I goes from 1 to n fxi theta upon xi square into I, which is an indicator function of theta to infinity xi. Now, this is for all xi's are greater than equal to theta. The condition has been given here. So, I have taken that. Now, for all xi's greater than equal to theta, x1, which is the ordered statistics of 1, should be greater than equal to theta. If x1 is greater than equal to theta, then all the above ordered statistics x2, x3 up till xn will be greater than equal to theta. To convert this, we will be taking L theta is equals to theta raised to the power n summation I goes from 1 to n 1 upon xi square into I theta to infinity x1. Okay. So here by comparing by factorization theorem, we can see that the only thing that it is dependent on is x1. So hence we can say that summation of sufficient statistic for the given PDF is minimum x1, which is minimum of all the xi's. Okay. So option number C will be the correct option for this question. Now moving towards another question, question number 3. Here we have been given another PDF, distribution of another PDF. So here again we will be talking about the likelihood ratio. Likelihood ratio states that L Lx1 upon Lx0 should be less than equal to K dash. Okay, this is the likelihood statement. Now, first of all, we have to calculate the likelihood function. The likelihood function will be beta raised to the power n e raised to the power minus beta summation xi. Summation xi can be written as nx bar minus n theta. This is the likelihood ratio. Now, under null hypothesis, it has been given that beta is equals to 2 and theta is equals to 3. And under alternative hypothesis, it has been given as beta is equals to 4, theta is equals to 2. And we have to find the best CR. So the best CR can be found by this. To calculate this, we will be putting these two values in the numerator and the denominator of these L, and then we'll be getting it. So it will be beta, which is 2 raised to the power n e raised to the power minus 2 n x bar minus theta 3n upon 4 raised to the power n e raised to the power minus 4 n x bar minus 2n is less than equal to k. Now on solving this statement, you will be getting the value of, for x bar, you will be getting the value of your best CR, and option number D will be your final value. I'm telling you the answer. You can calculate that by your own on taking log and multiplying it on other side. We are not wasting time in calculation. So option number D will be your final answer for this question. Now moving towards question number 4. Question number 4 gives us two statements. First of all, this random sample has been taken from normal distribution and parameters mu is known. So only one parameter is known. First statement states that CR bound for variance of unbiased estimator sigma is 2 theta square upon n, where theta is equals to sigma square. This CR lower bound, CRLB, is not the only thing that has been wrong here, that it is for sigma square and not for sigma. The only thing that has been missing here. So this statement is wrong. The first statement is wrong. Then second is, an unbiased estimator of sigma is this. Now if we calculate the unbiased estimator of sigma, it will be sigma root 2 by pi. If we calculate the expected value of this, it will come out to be this, which is not equal to sigma, and hence we can say that it is not an unbiased estimator. So this question has option number D as your correct answer, that neither of the statements are true. Moving towards another question, which is question number 5. Question number 5 has given us a PDF of fx e raised to the power minus theta and further confidence interval, and they have asked us to calculate the value of beta. First of all, let us see that PDF has been given to us. PDF of a single observation. So PDF of a single observation is e raised to the power fx is equals to e raised to the power minus x minus theta. Now if we calculate the CDF of single observation, it will be 1 minus e raised to the power minus x minus theta. Okay, this is very easy. We have to integrate it. So it is our CDF. Now if we calculate the survival function of a single observation, then it will be equal to 1 minus fx. So it will be equal to e raised to the power minus x minus theta. We have calculated for the single observation. Now we will be calculating for the minimum of all the observation, which is xi. So for calculating the minimum of all the observation, first of all, the survival functions will be calculated. The survival function of x1. If we calculate the survival function of x1, then it will be equal to probability that x1 is greater than y is equals to 1 minus fy raised to the power n. Now 1 minus fy will be e raised to the power minus n x minus theta. This is our survival function for x1. Now from this we can calculate our CDF for x1. The CDF of x1 will be f x1 y, and it will be equal to, here one change will be there, it will be y minus theta, because we are changing the variable. So f x1 y will be equal to 1 minus e raised to the power minus n y minus theta, and the PDF of this function x1 will be e raised to the power minus n y minus theta. Okay, final we have got. Now we have to check the distribution. So for checking the distribution, first of all we have to check the limits. So limits have been given to us as x1 minus log 40 upon n and x1. And the other limit that has been provided to us is that it lies between theta. So it will be x1 in the middle, the lower limit will be theta, and the upper limit will be theta plus log 40 upon n. This is our final limits that we have calculated for xi. Now to calculate the value of beta, it will be equal to beta is equals to integration from theta to theta plus log 40 upon n into n e raised to the power minus n y minus theta. This will be the final value. Now here we will be converting. Let n y minus theta is equals to z. So dz is equals to n dy. If we put the values here, it will be beta is equals to, if it is equals to theta, then z will be equal to 0, and when it is equal to this, then it will be equal to y ln 40. So here we have to put the value n into e raised to the power minus z into n 1 upon n into dy. So this 1 upon n get cancelled, and it is equals to e raised to the power minus z with the sign of minus with the limit 0 and log 40. If we put the values of the limits, then we will be getting minus 1 upon 40 plus 1, which is equals to 39 upon 40, which is nothing but equal to 0.975, and hence option number D is the correct answer for this question number 5. Moving towards another question. Question number 6. Question number 6 has given us two statements that if xi follows a normal distribution with mean theta and variance sigma square, so and sigma square is known and theta is unknown. The first statement states that MLE of e raised to the power 2 theta is e raised to the power 2 x bar with bias e raised to the power 2 sigma square upon n minus 1, which is the correct statement for question number 6. Now, if we talk about statement number 2, which is an unbiased estimator of e raised to the power 2 theta is e raised to the power 2 x bar minus 2 sigma square upon n, which is also the correct statement for question number 6. And hence, option number C is the correct option for question number 6, which states that both the statements are of this question are correct. Now moving forward to another question, which is question number 7. They have given the probability distribution function, a probability mass function of a discrete random variable, and they have told us to calculate moment estimate of theta. So first of all, we have to calculate expectation of x. To calculate expectation of x, the formula is summation over x into p raised to the power x is equals to x. So it will be 1 into probability x is equals to 1 plus 2 into probability x is equals to 2. Now putting the values of probability x equals to 1, which is 2 1 minus theta upon 2 minus theta plus 2 into theta upon 2 minus theta. Okay. Now here we can solve it because base is same is 2 minus 2 theta plus 2 theta upon 2 minus theta, which will be equal to 2 upon 2 minus theta. Okay, we have solved this. Now since we have to calculate the moment generating function, the moment of this, then we have to put it equal to x bar, because we know that mu 1 dash is equals to x bar for this probability distribution. So putting it equal to x bar is equals to 2 upon 2 minus theta. It will be 2x bar minus theta x bar is equals to 2. So 2x bar minus 2 upon x bar is equals to theta cap. And on further solving it, we can get the answer as 2 1 minus 1 upon x bar is equals to theta cap. So hence our option number C is the correct option for this question. The final value of theta cap is 2 1 minus 1 upon theta bar, is x bar. I hope that it was clear. It was an easy one. Now here they have asked us to calculate the MPCR of size 0.10 for testing H0 and against H1. First of all, the most powerful critical region, we have to calculate likelihood of H1 upon likelihood of H0 is less than equal to K. This we have to find. So likelihood of H1 is 4x cube upon 8x raised to the power 7 is less than equal to k. If we cross them all, we will be left with 1 upon 2x raised to the power 4 less than equal to k and 1 upon x raised to the power 4 less than equal to k dash. Let us say it is equal to C. One thing we have to change here is this sign. It is greater than equal to. And from here, we can conclude that x raised to the power 4 is less than equal to c. So we have got a variable c which we can use in calculating this. So first of all, under h0 we will be taking it. Under h0, probability that x raised to the power 4 is greater than, this is our CR, critical region, it is greater than equal to C, given that H0 is true, is nothing but equal to integrate 8 x raised to the power 7 dx with the limit 0 and C. On solving it, we will be getting C raised to the power 8. Now this has been given to us as 0.10. So C will be equal to 0.10 raised to the power 1 by 8. Let us consider this in another equation. So under H1, alternative hypothesis, probability that x4 is greater than equal to C given H1 is equals to, with the limit 0 and C, 4x cube dx will be equal to C raised to the power 4. And since C has the value this, so we can put it 0.10 raised to the power 1 by 8 whole power 4. If we cut them down, we are left with under root of 0.10, which gives option number A as your correct answer, under root of 0.10. That is how you solve this question in the examination. Now moving towards question number 9. Question number 9 has given us exponential distribution and they have asked us to calculate sufficient estimator. Again using factorization theorem or Neyman factorization theorem. First of all, we have to calculate the likelihood of this fx theta. If we calculate it, it will be 1 upon theta raised to the power n e raised to the power minus summation xi upon theta. Now here, if we now we know that likelihood is nothing but equal to g tx theta into h theta, and here if we compare it, then tx is nothing but equal to summation over xi. This is our Tx. So hence our option number D is the correct option of this. The sufficient estimator of theta is summation over xi. I goes from 1 to n. Now moving towards another question, which is the last one for today's lecture, is question number 10. Minimum variance bound estimator for sigma square, they have asked. For calculating minimum variance bound estimator, we have to pre-know the Fisher information and everything about that. So first of all, we have to calculate L theta. If we calculate L theta, which is standard normal distribution, 1 upon sigma root 2 pi 4 raised to the power n exponential summation xi minus mu is 0 upon 2 sigma square. Okay, so for solving this, we can upon 2 sigma. Okay, on solving the likelihood ratio estimator and then differentiating this with respect to theta, we will be getting some value. After we will be getting some value, suppose we are getting minus n upon 2 theta plus summation xi upon 2 theta square. So on finding the likelihood and then differentiating it with respect to theta, we can finally conclude that it is 1 upon 2 theta common. Then we are only left with summation xi upon theta minus n. So from here we can see that summation xi upon theta is equals to n should be equal to 0. Now if this is equals to 0, then here theta cap, you will found it as summation over xi square. It is square upon n as the MVB, which is minimum variance bound estimator for sigma square. So this was the final answer, and hence our option number A is the correct option for this question. So that is how we will solve the question of statistics paper 2, and I hope that you understood every question. Many of the question I have not done in detail and left it for concluding for you or for calculating for you. If you face any doubts in solving them, then you can ask us in the comment section, and we will be taking them as the first priority in the next coming lecture. All the best. Thank you.
Welcome to StatUp Academy, India's exclusive coaching for ISS, where statistics meets excellence. StatUp Academy,